Hello, I just wanted to talk to you guys about perfect square trinomials and completing the square because that's going to help with the set of your turn to play problems that you have to do this week. So let me just give you a couple examples of perfect square trinomials and we'll talk about what that means to be a perfect square trinomial. How could you look at a polynomial and just tell that it's perfect square trinomial? And how can we use that then to do some process called completing the square? So here are some examples of perfect square trinomials. X squared minus 6x plus 9, x squared plus 12x plus 36, x squared plus 20x plus 100. And I'll just do a fourth one here. X squared minus 24x plus 144. So these are all examples of perfect square trinomials. Now, what the heck does that mean to be a perfect square trinomial? I can see the trinomial part, but what does it mean to be a perfect square? Well, let's go through and factor each of these. So if I were to factor them, these are all easy general trinomials. Again, easy because the leading coefficient is 1. General because it follows that nice pattern of the exponents that the middle term is half the exponent or half the power of the first term, and there is nothing on no variable on the third term. And obviously it's a trinomial. All right, so we're going to factor using easy general trinomial technique. So we're looking for two things that multiply to 9 that add to 6, and both of them are negative. All right, so that would be x and x right here. Two things that multiply to 9 are 1 and 9 or 3 and 3, and only 3 and 3 will add to 6. And then they both have to be negative in order to get negative 6. So we have x minus 3 times x minus 3, but the shortcut to write that is x minus 3 squared. We have the same factor twice. All right, let's factor this next one. Again, it's an easy general trinomial, so we're going to use easy general trinomial techniques. We're looking for two things that multiply to 36, that add to 12, and both are positive. All right, so that would be x plus 6. And x plus 6. There are other things that multiply to 36, like 4 and 9, or 2 and 18, but none of those other combinations give us the 12 when we add them. All right, and again, I can write this as x plus 6 squared. All right, if we do this here, right, I'm looking for two things that multiply to 100 that add to 20, and both are positive. It's going to be x plus 10 times x plus 10, or x plus 10 squared. So I'll skip the last one. I think you get the hang of it by now. But what I'm noticing in each of these is that when I factor them, I get identical factors. And so that I can write it as a square instead of two separate ones. Think about something that doesn't factor like that. Like let's say x squared minus 5x plus 6. All right, I could write this as x minus 3 times x minus 2. The negative 3 times negative 2 multiply to give me positive 6, and then they add together to give me the negative 5. This factors into two separate binomials, but they're not the same, so I can't write it as the square of a single binomial. All right, so that's what makes a perfect square trinomial. It factors into two identical binomial factors. Okay, so then how can we take a polynomial, and again, let me write them down here in their unfactored form again. What is it about a polynomial that we could look at and say, oh, that is a perfect square trinomial? All right, let me write our fourth one here, even though we didn't factor that. Okay, so when we factored this, we got x minus 3 squared. When we factored this, we got x plus 6 squared. When we got this, we got x plus 10 squared. And when we would have factored this, we would have gotten x minus 12 squared. Now, one thing I want you to notice is that in every one of these cases, or sorry, let me say this. In every one of these cases, this last term was a perfect square. right? 9, 36, 100, 144. And it wasn't just a perfect square because of the number, it's also a perfect square because of its sign. -3 times -3 gives us +9, or +3 times +3 gives us +9. Had this been a -9 at the end instead, this is not a perfect square because there is no single number that we can multiply by itself to get -9. So the first thing is this last term right here has to be a perfect square. It has to be plus a square so that it's a positive square, right? So this last number has to end up being a square. Now let's look at this right here. So first of all, these could be positive or they could be negative. The sign here is not going to be significant in deciding whether it's a perfect square or not. It will be significant in how it factors, but not whether it's a perfect square, unlike this where this must be positive. Okay, so now let's look at all of these. And I'm going to compare them to what we got in each of these cases. All right, so what do you notice about this middle term, the coefficient of the middle term? Actually, we can even take the sign with it. The coefficient of the middle term and this factor that we ended up, or this number that we used in our factoring. So hopefully here you can see that we have a -6 and a -3 here, a +12 and a +6, a +20 and a +10, a -24 and a -12. So what relationship do you see between these two columns right here? All right, hopefully you're saying that this is twice as big as this, or this is half the size of that. All right, here 6 is half as big as 12, or 12 is twice as big as 6. And again, it's +6, so twice +6 is +12. Here this was -3, so twice -3 is -6. +10, twice that is +20. -12, twice that is -24. We also are noticing, and I think I might have just said this, we noticed these were all perfect squares, but notice that this is the square root of it, just the number part, not the sign part necessarily, although the sign could also be. So square root of 9 is 3, square root of 36 is 6, square root of 100 is 10, square root of 144 is 12. Right, so the things that we're looking for to make sure that this is a polynomial, that this polynomial is a perfect square trinomial, is that the last term is a perfect square. That last term has to be added. That middle term has to be, let's look at this, the square root of this, 3, doubled has to give us this. So take the square root of that and double it, gives us 6. Take the square root of this, we get 6, double it, we get 12. Take the square root of 100, it's 10, double it, we get 20. Take the square root of 144, we get 12, double it, we get 24. Right, so if we were to just create a perfect square trinomial, let's think of a perfect square. So let's say x squared, and then let's say we end with plus 121. Right, that's the square of 11. So again, I have to have this be positive. I have to have that be a perfect square. And then if we think what would have to go in here to make sure that this was truly a perfect square trinomial, well, the relationship we're noticing up here is I take this last term and take the square root, so I'm going to get an 11, and then I have to double it to get the middle term. All right, and then let's finally talk about this sign here. Again, we've mentioned it before, but let's say it once again. This sign right here and this sign right here match up. This sign right here and this sign right here match up. This and this match up. This and this match up. So really, we could make this either positive 11 or, oops, sorry, duh, I didn't double it, 22, sorry. You were all probably screaming, wait, Mrs. Taylor, that doesn't make sense. I could do whatever sign I want in here, but then when I go to factor it, I'm consistent, like there. Gosh, since I screwed that up, let me do one again. So let's say we have plus, let's do plus 25. So we're saying, well, what goes in here to guarantee that that is a perfect square trinomial? Well, I would have to get the square root of this, which would be 5, and then I would have to double it to put it in here. And then I would, again, it could be plus 10x, it could be minus 10x. If it were plus 10x, this would be x plus 5. Here it would be x minus 5. All right, so again, if we were to just kind of summarize, in a perfect square trinomial, let's say this, half the middle term squared, half the coefficient of the middle term, not just the, right, half the coefficient of the middle term squared is the constant term. All right, so I take half of this, 22, take half of it as 11, square it, I get 121. Take half of this, 5, square it, I get 25. All right, half of this squared, I get 25. All right, so in a perfect square trinomial, half of the middle term squared is the constant term. If there is not that relationship, then it's not a perfect square trinomial. Okay, let's just try one more like that. All right, so then, actually, let me just give you a couple here and you tell me whether they're perfect square trinomials or not. So x squared plus 6x plus 10, x squared plus 14x plus 49, x squared minus 4x minus 4, x squared minus 2x plus 1, and x squared minus 11x plus 121 over 4. Okay, so let's go through. Again, our rule is if it's a perfect square trinomial, then half of the middle term, half the middle coefficient squared gives me that. So if I take half of 6, I get 3, square it, I get 9. Nope, no good. Half of 14 squared, or half of 14 is 7, squared is 49. Yes, this is one. All right, let's try this one. Half of negative 4 squared, well, half of negative 4 is negative 2, squared is positive 4. That's not what we have. Remember, this has to be positive. So any that have a negative right there, you can cross them right out. They will not be perfect square trinomials because when I take half of this, whether it's positive or negative, and then square it, that will give me a positive value. So no. All right, half of negative 2 is negative 1. Negative 1 squared is positive 1. Yes, this is. All right, this one's a bit of a doozy because it's an odd number, but if I take half of 11, it's 11 halves, and then even negative 11 halves, and if I square that, negative times negative is going to give me a positive, so I'm just going to ignore that. 2 times 2 is 4, 11 times 11 is 121. So yes, this also is. Okay, so that is what perfect square trinomials are. That's how you can recognize a perfect square trinomial. But a lot of times when you're starting out, okay, so then let's say this. Next step is if I gave you this polynomial, this beginning of a polynomial, let's say it was x squared plus 16x, and I say, what do I have to add on to make this a perfect square trinomial? What would this have to be in order for it to be a perfect square trinomial? Right, so we already said that I take half of the middle term, right? So half of the middle term is positive 8, and then I square it, and that's what has to go right here. So in this case, C would have to be 64. So what do I have to do to make this a perfect square trinomial? I have to write it as x squared plus 16x plus 64. Right, that would make it a perfect square trinomial. Let's do another one. Let's say I had x squared minus 24x, I think I already did this one, yeah. Let's say minus 30x plus c. What would I have to do to make this a perfect square trinomial? Well, I have to take half of this, which is negative 15, and then I have to square it and put it here. So negative 15 squared is positive 225. So this would have to be x squared minus 30x plus 225 for it to be a perfect square trinomial. Now, sometimes people just write it like this. I'm going to do the same one. And they'll leave a blank there so that we get ready for whatever needs to go there. And then at the same time that they're figuring out what goes there, they also factor it, right? So when we factor it, notice in each of these problems that we did right over here, when we factored it, that x squared comes down, just ignore this for just a second. This x squared, when we factor it, comes down in the parentheses as an x because we're splitting it basically into two parentheses. This -6 comes down as half, so it's -3. And then we take this, the 3 squared, and pop it right up there. All right, so when we're factoring the x squared, because we're splitting it into two equal factors, it's going to be x and x in our two parentheses, which we're grouping together as a squared. This -6 is going to come down as half, so it's going to come down as -3, and then we put +9 because it's 3 squared up here. Same thing here, ignoring this. This x squared comes down as an x. This +12 gets split in half as a +6, and then we square the 6 and pop it up here. So sometimes people will do both of those steps at once. So here, if I wanted to factor, I know it's going to be a perfect square trinomial because I'm going to make it that way. So this is going to come down as an x. The -30, I'm going to bring half of it down here. So it's going to be -15. And then up here, I'm going to take the 15 squared and pop it right up here, which is 225. All right, let's take a look at the x squared minus 2x plus 1. We already knew that that's a perfect square trinomial. Sorry. Now I'm saying if we didn't know it was, and I gave you that much and said, what do I have to do to make it a perfect square trinomial? I'm going to get ready, factoring, because I'm going to make it a perfect square trinomial. This is going to come down as an x. This is going to come down as half of -2, which is -1. And then I'm going to square the 1 and pop it up here. All right, let me do one more. So let's say we had x squared minus 18x plus what? What do I need this to be to be a perfect square trinomial? I'm going to do both things at one time. So I'm going to factor it, and then I'm going to figure out what needs to go up here. So in order to factor it, this is going to be x. Half of minus 18 is minus 9, and then I'm going to pop this up here as 9 squared, which is 81. All right, so then this is what I need to make this a perfect square, and this is its factored form. Right, and then that one with the minus 11, the x squared minus 11x plus what? Again, I'm making it a perfect square trinomial. In order to do that, I take the x, I do half of minus 11, which is minus 11 halves, and then I square it. Again, this is a lot less pretty, but still doable, 121 fourths. Right, so here is the value that makes that a perfect square trinomial, and this is its factored form, and it's factored into a perfect square trinomial. Now, one last thing. I mentioned at the beginning that this video was on perfect square trinomials and completing the square. That process that we were just doing, where we had the x squared plus 20x plus what makes that a perfect square, that process is called completing the square. Why is it called completing the square? Well, first of all, it makes a perfect square trinomial. But just again, think about what a square is. It's a geometric shape that's even, that has the same number or the same length on each side. And we can think of squares, or a lot of times when we think of multiplication, we can think of rectangles because of their area. That's a good model for it. So essentially what we're doing, you know, like if we were trying to find 3 times 4, we could say, well, that's the same as a rectangle that's 3 on one side and 4 on the other side. So the same thing here with polynomials. We could form a square because both factors would be the same. So we could say this side was x plus 10 and this side was x plus 10, and we would find the area of that square that had those two different lengths. So that's another way that you can think of square. It's like an area model. Where we're multiplying two things, but they form a square because their side lengths are equal. Okay, hopefully this helps. If not, let me know and I will give you some more examples. Bye.